Hi everyone, my name is Ayan Omar Siddiqui. My student ID is S224777251, and in this, I'll be providing a short demo. I'll show DNS as action. DNS action is using uh, tools and Wireshark. I'll provide you with an insight on how a name like a website like www.deacon.edu.au becomes an IP address, what a DNS packet looks like on the wire, and why DNS normally uses the UDP. So yeah, let's just get right into it. So first I'll show you how to query DNS from the command line. I'll use dig because it's concise and shows the raw answer format. So I'm just gonna have this command open up over here, not this one, but yeah, this one, with the dig and with the type A, and I will be pressing the enter button. Here, as you can see, we have 4 columns in which we have the name, TTL, class, and then the type, and then the R data. So the type A row gives the IPv4 address. That's a numeric destination used by routers and switches to forward packets. So TTL is the time to live value, and it tells resolvers how long they can catch this answer. Now I'll do the same thing with the IPv6. Yep. So now I'll query an IPv6 address with the dig plus no all plus answer with 4 A's, and then this site we're going for the Deacon right now. So I'll be pressing enter. So here you go. That's where I got the same 4 columns, but this is for the IPv6 address. I'll do the same thing with the MX record, in which the mail service is stored. I'll be pressing enter, but as you can see, I'm not practicing any mail work over here, so that's why for there's no as such response or output over there now. So that's how I got the data from the dig. And some people prefer NSLOOKUP, but we can do the same thing by just typing NSLOOKUP dash type is equal to mx deacon.edu.au. NSLOOKUP is more like common on Windows. A dig is more flexible on Unix and Mac-like systems, so that's why I just went with it. Now, for the main topic of this video, for the main thing, I'll be showing how to demonstrate and appear the main queries on Wireshark. So I'll be opening my Wireshark, and I will be running my capture over here. So I'll just press that, and then I'll just run the same command line over here, the IPv4. I'm pressing enter, and as you can see, we have the output here again, and I'll just go back and then just stop the filter over here. So I'll just stop the filter over there and then just type in DNS, for that's what we're basically looking for. We have a DNS query over here of Deacon, so we will be opening that. So as you can see, we have the analysis of the packet we got over here. So as you can see, we have first the transaction ID, in which the 0xC892. So this hexadecimal number binds the response to this specific query. The resolver and client use this to match pairs. Looking at flags, over here we have, as a query, we'll often see them as recursion desired, because it means basically the clients ask the resolver to perform a recursive lookup on its behalf. It's in the query section. We can see the name requested and type A over here, type A, and now I'll find the response back in the same transaction ID. So here's a response over here, and We can see the type, the A, the TTL, and everything present over here. So that is basically used for the actual IP to send packets. So, and coming over to the UDP, under the UDP protocol layer, we can see the query had an ephemeral source port and destination port 53. The response spoils these ports. This is why DNS uses UDP.port is equal to 53. The server listens on 53 basically, so that's the main point of the destination port over here. So yeah, that's the pretty much the Wireshark demo over here of the DNS. So if we need reliability or a bigger response, DNS can use TCP. You can force TCP intake with plus TCP, and then we'll see that basically the TCP packets in the capture. But for standard lookups, UDP is preferred because it's faster and has lower overhead. So that's why UDP is more preferred. Um, Coming on to the main topic of this demo, going beyond the basic content of the DNS. So in SIT202 content, we study routing and packet forwarding. So DNS is the step before that. The application asks DNS for an IP, and only then do routers and forwarding tables take over. So if DNS fails, nothing else matters. So you have no address to route to. So that's why DNS is that important. So yeah, that's basically the end of the demo. Yeah, and I have provided my analysis of Wireshark and take on DNS. So yeah, thank you. That's the demo. Thank you so much for watching.